Partial fractions decomposition. Two distinct linear factors. In this example, you can see a fraction with a denominator that is a quadratic trinomial. In order to decompose this fraction, we start with factoring this quadratic trinomial. As you can see, here are two factors that are linear because x is raised to power of 1 and distinct because they are different. Now we write a sum of two fractions where the denominator of each is one of the two linear factors and the numerator is a constant. We may choose a and b or any constant you like. The goal now is to find the values of a and b. To do so, we need an equation. To find this equation, we start with combining the two fractions we wrote. We combine the two fractions by making common denominators. Simply multiply the first fraction with x plus 3 up and down, and multiply the second fraction with x plus 2 up and down. Now my left-hand side, which is the original fraction, is equal to the combination, which is one fraction with the new denominator x plus 2 times x plus 3, while the numerator is the sum of a times x plus 3 and b times x plus 2. By comparing the two sides of the equation, we can simply ignore or cancel the denominators, since they are exactly the same, and write an equation of the numerators only. To find the values of a and b, we choose x to be -3 and substitute in both sides of the equation in order to cancel a and find b. After simplifying both sides of the equation, we get -4 equals -b, and by dividing both sides by -1, we have b equals 4. Now we choose x to be -2 and substitute in both sides of the equation in order to cancel b and find a. After simplifying both sides of the equation, we get 3 equals a, or a equals 3. Now we write our final answer by replacing the values of a and b. So the partial fraction decomposition is 3 over x plus 2 plus 4 over x plus 3.